Hi guys, this is Saurav here and welcome to another Aspire series of Advanced 2019. We are conducting a number of such sessions so as to help you become crazy, amazing for the JEE Advanced 2019. This is our endeavor from the whole team of Vedantu that your sailing in JEE 2019 Advanced should be as smooth as possible. So with that thing in mind, this is the second lecture for liquid solutions, and I discussed liquid solution earlier. In the lecture 1 we had discussed about ideal solutions, and as promised in this lecture series I will be discussing about liquid solutions 2, that is non-ideal solutions, with a few tidbits from the ideal part. Now it is important that you review the previous session so that you have a sound grasp on the concepts that we would be utilizing in this one. Having said that, it is imperative that you sit with a pen and a paper so that you solve questions simultaneously as I give it to you. As like our last session, we will be discussing certain problems and discussing certain concepts behind them, and this is the schedule for the forthcoming sessions that you should always keep in mind, that liquid solution, electrochem coordination. So I will be taking sessions until 20th February, and then Pahul sir will start with his epic general organic chemistry sessions. So I guess you're enjoying his epic GOC sessions. Also you are thorough with all the amazing content coming from Vedantu, especially the Aspire series videos. So without further ado, we will start today's session, and the first question for today's session is this. This looks like a very wordy question, but let's read it. How many of the following solutions show positive deviation from ideal behavior? How many of the following solutions show positive deviation from the ideal behavior? Any options? No. So this question is of a integer type question. I told you earlier that I'd be taking questions of mixed bag, single option, integer, multi-option correct questions, just so that you guys are on your feet. Okay, so this question is about ideal behavior. We have how many options? 6 times 3, we have 18 options to choose from, 18 solutions to choose from. How do we make that decision? Let's go ahead. So to make this decision, what we need to know, that what is the ideal solution and what is a non-ideal solution. An ideal solution, my dear students, is one which follows Raoult's law. So what do we understand from that? So as we know, Raoult's law predicts that if you take two solutions A and B, two liquids A and B, and you make a solution out of them. So when you make a solution out of them, you will utilize some amount of A and some amount of B. So according to Raoult's law, the vapor pressure for the solution will be equal to the mole fraction of A times pressure due to the pure solvent A, mole fraction of B times pressure due to pure solvent B. Now this is our P total, which we can also write as P of solution. Now in a number of cases, this is an ideal scenario. It looks like Dalton's law of partial pressure, doesn't it? Looks like Dalton's law of partial pressure, mole fraction times mole fraction. So it looks like Dalton's law of partial pressure. Now the point is, in a number of scenarios, this total pressure is not equal to the sum, and that is non-ideal solution. So there are two types of non-ideal solution, if you recall. First non-ideal solution is one which shows positive deviation, in which P total at one specific point, कहाँ पे? not all concentration at one specific point is more than P predicted of solution. आपने जितना प्रेडिक्ट किया सम से उससे ज्यादा हो जाएगा. ओके, दिस सम से जो आपने निकाला उससे ज्यादा हो जाएगा. ओके, एंड नेगेटिव डेविएशन is P total, which will be less than this. Now, how do we analyze this in terms of solution? कैसे एनालाइज कर सकते हैं? Now, एक चीज याद रखिए, आइडियल सॉल्यूशंस वो होते हैं जिनका बिहेवियर एक जैसा ही होगा. There would be not too much of a difference, like हेक्सेन हेप्टेन, इथाइल अल्कोहल मिथाइल अल्कोहल, इन दोनों की प्रॉपर्टी के बीच में बहुत ज्यादा डिफरेंस नहीं है. So they will behave as ideal solutions. नॉन आइडियल सॉल्यूशंस में हम डिफरेंस कैसे निकालेंगे? वेपर प्रेशर तब डिक्रीज करता है, वेपर प्रेशर तब डिक्रीज करता है जब अट्रैक्शन होगा, एंड वेपर प्रेशर तब इंक्रीज करेगा जब अट्रैक्शन कम हो जाएगा. समथिंग विच विल डिसरप्ट द अट्रैक्टिव फोर्सेस. सो पॉजिटिव डेविएशन इज डिसरप्शन ऑफ अट्रैक्टिव फोर्सेस एंड नेगेटिव डेविएशन इज inclusion or increase of attractive forces. That means, let's say ions are created, and disruption means a substance which earlier had some attractive interaction, but कोई चीज बीच में आ गई और उसका attractive interaction decrease कर गया. For example, आपने ले लिया water and ethyl alcohol. वाटर के बीच में बहुत स्ट्रॉन्ग हाइड्रोजन बॉन्ड बनते हैं. नाउ द मोमेंट यू पुश इथाइल अल्कोहल डज नॉट फॉर्म दैट स्ट्रॉन्ग हाइड्रोजन बॉन्ड्स. सो व्हाट विल हैपन? वाटर विल बिकम सेपरेटेड फ्रॉम ईच अदर एंड इथाइल अल्कोहल विल बी सिटिंग बिटवीन इट. सो दैट विल कॉज पॉजिटिव डेविएशन. नाउ वाटर मॉलिक्यूल्स कैन मूव आउट इन द वेपर स्टेट वेरी इजीली. अगर आपने वाटर को HCl के साथ मिला दिया तो क्या होगा? देखते हैं. If you mix water with HCl, then H2O mixed with HCl will produce H3O plus Cl minus. Huge degree of attraction because ions are produced. Less attraction because only hydrogen bonding. Okay, so if there is more attraction in the liquid state, less vapors are created, and then it will cause negative deviation. Remember this: more attraction in liquid phase, more attraction in liquid phase results in lower vapor pressure. Less attraction, more vapor pressure. Lower vapor pressure, negative deviation. More vapor pressure, positive deviation. Clear? Let's try to solve the question. देखते हैं क्वेश्चन में क्या था. So, question was this. Let's analyze each and every solution step by step. N-hexane, N-heptane एक जैसा रिलेशन है. सो हम जो आइडियल होगा उसके बगल में I लिख देंगे और जो पॉजिटिव होगा उसके बगल में पॉजिटिव लिख देंगे, एंड द वन सॉल्यूशन व्हिच विल ट्राई टू शो नेगेटिव डेविएशन विल राइट नेगेटिव इन फ्रंट ऑफ इट. ओके, सो दैट विल बी द लेजेंड दैट वी वुड बी यूजिंग. सो दिस इज हाउ इट वुड गो लाइक. सो N-hexane, N-heptane similar nature, ideal. Similar nature, ideal. CCl4, SiCl4, similar nature, ideal. H2O, HCl, negative. बेंजीन एंड इथाइल अल्कोहल, बेंजीन एंड इथाइल अल्कोहल, इथाइल अल्कोहल के बीच में बेंजीन आ गया, इथाइल अल्कोहल के बीच में बेंजीन आ गया, क्या होगा? अट्रैक्शन डिक्रीज कर जाएगा. इथाइल अल्कोहल विल बिकम सेपरेटेड फ्रॉम ईच अदर. सो दिस विल बी positive, this will be positive, this will be negative. Benzene, acetone, same thing. Acetone and acetone molecules have dipole-dipole interaction. Benzene बीच में घुस गया, benzene molecules come between, dipole-dipole interaction decreases. Positive. Hexane and ethanol, hexane and ethanol, what will happen? Positive. Reason? Ethanol hydrogen bonding, hexane non-polar solvent, ethyl bromide, ethyl chloride, ideal. Benzene toluene, ideal. Acetone aniline, एसीटोन एनिलीन, इन दोनों के बीच में रिएक्शन हो जाता है. अगर आपको याद हो कार्बोनिल केमिस्ट्री में, एसीटोन एंड एनिलीन दे रिएक्ट विथ ईच अदर. एनी टू सब्सटेंसेस which can react with each other will always show negative deviation. Negative. Carbon disulfide acetone non-polar, dipole-dipole interaction. Positive. CCl4 CHCl3. CHCl3 has some degree of you can say dipole-dipole interaction, but CCl4 does not. So this will be positive. H2O ethanol, positive, that I've already told you. Chlorobenzene bromobenzene, ideal. Chloroform acetone react with each other to form chloritone. So reaction होता है, इसका मतलब negative होगा. H2O HNO3 ionization, negative. Creation of ions. Chloroform ethanol. Chloroform has less degree of dipole-dipole interaction. Ethanol more degree of dipole, like hydrogen bonding होता है, यहाँ पे hydrogen bonding उतनी नहीं है. So lesser degree of interaction, more degree of interaction. If ethanol and if chloroform comes between two ethanol molecules, interaction is disrupted. Positive. H2O methanol, positive. Acidic acid pyridine, acid and base के बीच में रिएक्शन होता है, तो ये हो गया negative deviation. This will be negative deviation. Okay, so how much time did it take to solve us this question? This took us less than 2 minutes to solve. मैंने को एक्सप्लेन कर रहा था, बट अगर आपको समझ में आ गया मेथड, यू कैन सॉल्व इट अंडर 2 minutes. लेट्स काउंट हाउ मेनी पॉजिटिव डेविएशन सॉल्वेंट्स आर देयर. सो पॉजिटिव डेविएशन हमें निकालना है 1 2 3 4 5 6 7 and 8. काउंट कर लीजिए, वी हैव 8. सो द आंसर फॉर दिस क्वेश्चन इज 8. 18 में से 8 op. Okay, easy. Let's move on to the next question. This is the next question. Let's just read the question first. Question is very wordy again, and it's a multi-option correct question. Slightly difficult, but not unsolvable. Let's read it. The following graph is plotted at constant pressure. If x and y represent the mole fraction of liquid and vapor phase respectively, which of the following statement is or are correct? Now, what you can see over here is a plot that we had discussed in the last class. Boiling point versus composition. लेकिन इस plot में हम infer क्या करते हैं? Now, if you have heard of a term known as fractional distillation, then in fractional distillation we separate two liquids by utilizing this property, using this plot. How do we do that? Let's find out. So what we do is, let's use this plot. In fractional distillation, remember that we are distilling a liquid. So जो ज़्यादा volatile substance रहता है वो जल्दी बाहर escape कर जाएगा. जो ज़्यादा volatile रहता है वो ज़्यादा जल्दी बाहर escape कर जाएगा. And so there are two fractions obtained. One is known as distillate and one is known as the residue. Okay, distillate will always be more volatile component and residue will be always less volatile one. Okay, लेकिन हमें पता कैसे चलेगा कि कौन सा ज्यादा volatile है, कौन सा कम volatile है? How would we know that which is more volatile, which is less volatile? By looking at the boiling point versus composition plot. Now remember, if vapor pressure is high, boiling point is low. If vapor pressure is high, boiling point is low. So this is benzene. Benzene is 1 at this point. Benzene is 1 at this point, and toluene is 1 at this point. So this point represents boiling point of benzene, and this point represents boiling point of toluene. Jahan the axis, this point where it is 1, benzene is 1 over here. You can see the plot. See, it is 0, 0.1, 0.2, 0.3, 0.4, and it's increasing to 1. So that means it is, and 1 is for toluene. So that means this is written for toluene. This is not written for benzene. अगर benzene के लिए मुझे लिखना होता, then for this I would have written 0.0 over here, 0.1 over here, 0.2 over here, and so on and so forth. Okay, so this is written for toluene. This is the boiling point for toluene. This is the boiling point for benzene. So if we look at the boiling points, whose vapor pressure is higher? Whose vapor pressure is higher? Boiling point of benzene is lower. So that means vapor pressure for benzene, pure benzene, is higher than vapor pressure for toluene. Is this clear? Vapor pressure for benzene is more than the vapor pressure of toluene. ये बिल्कुल clear हो जाना चाहिए आपको, ठीक है? Now let's move ahead and try to solve this question. इसको समझते हैं कैसे करना है. Now I had told you that this is for benzene, boiling point for benzene, and that was for toluene. This was for toluene. Now, if I try to identify what do we have to infer using this, we have to infer that at a particular point when we boil a liquid, तो vapor phase में कितना किसी का mole fraction रहेगा, ये हमें बताना है. Okay, how do we do that? We use something known as a lever rule. Lever rule का मतलब ये होता है, suppose I boil a solution of benzene and toluene in which mole fraction of toluene is 0.7. Listen to me very carefully. I boil a solution of benzene and toluene in which toluene has a mole fraction of 0.7. तो बेंजीन का कितना होगा भाई साहब बताइए? बेंजीन का हो जाएगा 0.3. ओके, बेंजीन मोल फ्रैक्शन विल बी 0.3. अब हम इसको बॉयल करते हैं, ठीक है? जब बॉयल किया जाता है तो वेपर सेम टेम्परेचर पे क्रिएट होते हैं. इट्स अ आइसोथर्मल प्रोसेस. ओके, इट इज क्रिएटेड एट अ आइसोथर्मल कंडीशन. सो दिस इज द boiling point of that solution. This is the boiling point of that solution. ठीक है? This is known as the liquid curve. This is known as the vapor curve. That means if I boil this liquid, look at the arrow. If I boil this liquid, it will create vapor, and उसको हमने ठंडा किया, condense कर दिया. When you condense the vapor, you will get a solution. In which toluene will be 0.4 and benzene will be 0.6. Do you understand this? हमने एक सॉल्यूशन लिया, उसको बॉयल किया, and then we condense it. I will get a solution. So this represents the mole fraction in the filtrate which is or distillate which is obtained. So this is representing the distillate and this represents the solution which we are boiling. Okay, so we started from 0.7, reached 0.4. So initially this was the scenario, this was the solution, and then we boiled it. We have benzene and toluene in the distillate as 0.4 एंड बेंजीन देखो इंक्रीज कर गया ना. मैंने क्या बताया था, जो डिस्टिलेट रहेगा उसमें जो ज्यादा वोलेटाइल रहेगा वो बाहर आ जाएगा. विच हुज वेपर प्रेशर वाज मोर, बेंजीन, दैट मींस इट इज मोर वोलेटाइल, तो उसका अमाउंट इंक्रीज कर गया. देखिए पहले सॉल्यूशन में जितना था उससे ज्यादा आपको बाहर मिल गया. ओके, सो द इन द डिस्टिलेट the amount of more volatile component will increase and less volatile component will decrease. अब distillate को लेके फिर से boil कीजिए, फिर से इसका amount increase करता जाएगा. So mole fraction increase कर रहा है, not the mole fraction is increasing. Okay, mole fraction is increasing, number of moles increase नहीं कर रहे हैं, mole fraction is increasing. Okay, that is good enough for us. Let's try to work out the problem by looking at what was asked in the question. So question में पूछा क्या गया है? So in the question it is asked, when X benzene, X represents mole fraction in liquid, X represents liquid, X represents liquid, Y represents vapor, and vapor को कंडेंस कराया गया तो इसका मतलब ये डिस्टिलेट ही हो गया. When we condense the vapor, it becomes the distillate. So, mole fraction of benzene is 0.5. Mole fraction of benzene is 0.5 in liquid, then mole fraction of toluene in vapor is 0.2. Let's see. What I do is, I draw a line like this. Okay? Lever rule. Something straight. This point is where benzene is also 0.5. This point is where benzene is also 0.5. I boil this, I obtain this. I boil this at this temperature and I obtain a solution in which the mole fraction, you see, mole fraction of toluene कितना है? 0.2. तो mole fraction benzene कितना होता है वहां पे? 0.8. हमारा ये आंसर करेक्ट है. Look at the next one. If mole fraction of toluene is 0.3, then benzene is 0.6. Let's see. Toluene is 0.3. 0.3 यहां पे. 0.3 is over here. I boil it. I will get this. Boil this. I will get this. हमेशा उधर ही मूव कर रहा है. Boil this, gets this. I get toluene 0.1. तो बेंजीन कितना मिलना चाहिए? 0.9. बेंजीन कितना लिखा हुआ है? 0.6. So it is incorrect. At this point, benzene will be 0.9 because toluene is 0.1. Let's look at the next question. Benzene is 0.3, then toluene is 0.4. Benzene is 0.3. Where is benzene 0.3? Benzene is 0.3 over here. Okay. Benzene is 0.3 over here. Boil this. How much is toluene? 0.4. Correct. Benzene is 0.7, then toluene is less than 0.3. Benzene is 0.7 where? यहाँ पे. Over here benzene is 0.7. I boil this. I boil this solution. I obtain a distillate What is the concentration of the distillate? 0.1 mole fraction of toluene and 0.9 mole fraction of benzene. So mole fraction of toluene in the distillate, I told you Y represents mole fraction vapor, or vapor is nothing but the distillate which you would be obtaining. So it is less than 0.3, which is also correct. So our answer for this question should be A, C and D. The answer for this question should be A, C and D. Okay, I hope you enjoyed this question, because this question is very very intricate, very very conceptual, very fun to. Okay, और इसको समझना बहुत difficult नहीं है, थोड़ा सा practice कीजिए, इसको आप फिर से plot कीजिए खुद से, try to work on the lever rule. Increases isothermal condition, वहीं पर decrease. Same, this and this point should be on the same temperature axis. Same temperature axis. Same temperature पे ये दोनों point meet करने चाहिए. Vapor के लिए जो liquid के लिए जो आपने टेम्परेचर लिया है, उसी टेम्परेचर पे आपको वेपर बनाना है. दिस इज लोअर वन इज फॉर सॉल्यूशन, upper one is for vapor. Okay, so before going on to the next question, I just wanted to tell you that you should download the Vedantu doubt solving app on the Vedantu app, so that your doubts are resolved on the go. So we have a huge team of doubt solving members who are solving about like 2000 doubts on a daily basis, and it will be amazing. So that if you like post your doubts, get it resolved and be happy about going back to your studies without any confusion, any questions at all. So please do download this, and with this message we'll move on to the next question. So next question is about something known as azeotropic mixtures. What is an azeotropic mixture? Azeotropic mixture is one which, if you boil, will not have a different composition in the distillate. Why is this? Usually what happens is that when you boil a solution, then whatever is more volatile separates out. But in an azeotropic mixture, we hit a roadblock. This roadblock comes because there is no corresponding vapor plot with respect to the liquid plot. If you remember the lever rule, we had in the same temperature axis a vapor curve and a liquid curve, a vapor curve and a liquid curve. But in this case, we do not have such a scenario. Now, how do we identify azeotropic mixtures? Azeotropic mixtures are formed when liquid shows positive or solution shows positive deviation and negative deviation. Let's read the question first. A liquid mixture having composition corresponding to point Z is subjected to distillation at constant pressure. Which of the following statements is correct about the following process? Now, to analyze this, let's take this temperature. Now, when we see that the temperature of the solution is temperature of one of the components is this, the another component is this, and one of the at an intermediate point is higher than the liquid which has the highest boiling point among the two liquids which are being mixed to form the solution. दो लिक्विड लेके हमने सॉल्यूशन बनाया A और B, और जिस लिक्विड का हायर बॉइलिंग पॉइंट था उससे भी ज्यादा बॉइलिंग पॉइंट हो गया, तो इसका मतलब कि डेविएशन कौन सा हुआ? नेगेटिव डेविएशन. Negative deviation means boiling point will increase because vapor pressure is decreasing. So this is a plot for negative deviation, or this is a plot for an azeotropic mixture which shows negative deviation. Now this curve is for liquid, this curve is for vapor. अब हमें identify करना है कि what is happening at point Z. Now what I do is, this is the composition axis and this is temperature composition axis. So what I do is, if I connect point Z with whatever is its boiling point, Z पे जो composition है, which is this, Point Z corresponds to a composition O and has a boiling point TB. But what I don't see over here is a corresponding vapor plot. This is liquid, this is liquid, this is vapor, बट इसके कॉरस्पॉन्डिंग कोई वेपर नहीं है. इसके अगर यहां पे हमने कॉम्पोजिशन लिया होता देन आई कुड हैव गॉटन अ वेपर प्लॉट. If I would have taken the liquid composition over here, I would have gotten a vapor plot. But at this juncture, at point Z, I do not have a vapor plot. That means if vapor plot is not present, and so the vapors which are created will be of the same composition as that of the liquid. Vapor plot not present, vapor plot not present, that means the vapor composition will be the same as that of the liquid. अगर vapor plot present रहेगा तो इसके corresponding ये vapor बन जाएगा. अगर इसके corresponding vapor plot नहीं present है तो वो liquid का ही composition vapor में भी आ जाएगा. So if I analyze the statement, the composition of the distillate differs from that of the mixture. No, distillate is obtained by condensing the vapor, but vapor's composition will be same as that of the mixture or the solution at point Z because there is no corresponding vapor curve. So this statement is correct. The mixture represents maximum boiling azeotrope. Obviously, maximum boiling azeotrope is obtained due to negative deviation. Obtained due to negative deviation. Maximum boiling क्यों बोलते हैं हम? क्योंकि जो boiling point में जिस दो liquids को मिला के हमने जिस liquid का boiling point ज्यादा था उससे भी ज्यादा liquid A, liquid B mixed together, but the solution's boiling point turns out to be even more than that. So this is known as a maximum boiling azeotrope. Next point. At point Z, the vapor pressure is higher than at any other composition. आपका यहाँ पे boiling point ज़्यादा है, तो अब हम इस liquid को ले लेते हैं. इसका boiling point सबसे कम है. If I take this liquid, pure liquid, let's say this is pure liquid A, this is pure liquid B, and assume that this is pure liquid A and that is pure liquid B, then this liquid has a vapor pressure higher than B, but this point has a vapor pressure lower than even B. That is the reason the boiling point of Z is higher than B. Vapor pressure increases, boiling point decreases, or vapor pressure decreases, boiling point increases. No confusion. इसको याद रखिए, boiling point increase कर रहा मतलब vapor pressure कम होगा. So Z has the vapor pressure higher than at any other point in the composition, which is incorrect. Vapor pressure lower than any other point in the composition. The mixture represents minimum boiling azeotrope, which is incorrect. So the correct answer for this question is A and B. This question is not very straightforward, but not very difficult to understand as well. आपको बहुत difficult question नहीं दिए जाएंगे azeotropic mixture पे. You'll be asked what type of solution it is, and you'd be asked through a graph to identify whether it represents maximum boiling azeotrope, minimum boiling azeotrope, or whether it represents positive deviation or it represents negative deviation. That's it. Okay, so let's move on to the next question. The last question is a very simple takeaway from whatever we had discussed in the last class. It is related to degree of dissociation. Something is given and some other information is given. Now it has been framed in a different manner, and I just wanted to present in front of you another way of looking at a question which can be presented to you in an advanced examination. Okay, so let's look at the question. The question talks about that 1 gram of a monobasic acid when dissolved in 100 grams of water lowers the freezing point by 0.465 degrees. Now lowers the freezing point by 0.465 degrees or kelvins makes no difference. Degrees है उतना से decrease कर गया. When an aqueous solution of 0.2 gram of the same acid is titrated with NaOH, it required 40 ml of N/12 NaOH. What is the degree of dissociation of the acid? So there are two informations which are given and I need to identify what is the degree of dissociation. So to identify the degree of dissociation, I need to know I, which is Van 't Hoff factor. So I start my question by writing what is given and then I will try to see what can be arrived at from the secondary information which is given. So delta TF, I know from the last class, delta TF is equal to I times KF times molality. So delta TF is given as 0.465, which is I times KF, which is 1.86. For molality, I require number of moles of the monobasic acid whose molecular weight is not known and mass of solvent is given as 100 grams. So I write 0.1 kgs. That gives me the molality. But this mass is not known. How do I know the mass? So I'll use the second information. How do I do that? Second information is two acid and base reaction takes place. Titration means reaction. So what I do is I utilize the idea of equivalents. Equivalents का idea ये कहता है the number of equivalents of two reacting substances will always be equal. Two reacting substances will always be equal. Equivalents will always be equals. Moles may or may not be equal. So 0.2 gram of the acid whose molecular weight is M, 0.2 gram molecular weight is M, monobasic, so N factor is 1. Weight by molecular weight gives the number of moles. Moles times N factor gives the number of equivalents. Now 40 ml of N/12, 40 ml of N/12, that is normality. Now normality दिया हुआ है, normality times volume. Normality times volume gives the number of milli equivalents. If volume is given in terms of milliliters, I'd have to divide it by 1000 so as to convert it into terms of equivalents. So one normality, remember this, normality times volume in liters is equivalents. Normality times volume in milliliters is milli equivalents. If I try to solve, M will be equal to 12 times 0.2 times 1000 by 40, which turns out to be 60 grams. If I incorporate that value over here, so I times 1.86 times 1 by 60 times 0.1 is 0.465. So this will give me 1.31 and this I will turn out to be equal to 1.5. I will turn out to be 1.5. If I is 1.5, let's say the acid is HA. आगे का इक्वेशन आपको मालूम है, HA plus A minus 1 minus alpha, alpha, alpha. So I will be equal to 1 plus alpha. So alpha कितना हो गया? 0.5. So आपका ये आंसर है कितना? What is the degree of dissociation? 0.5. Straightforward. No hassles, very easy, very, very effective. This is the method that you should use and a number of such problems can be presented in front of you. Okay, so this is the last problem of the day. I hope you have enjoyed the liquid solutions lessons and You have learned something new and try to practice this. Try to practice this. I have presented some difficult questions in front of you. Maybe these questions are something that you have learned earlier, and maybe these are some things which you are learning right now. But spend some time on them so as to gain certain degree of fluency, because liquid solution से एक question तो आपका आना ही है. And liquid solution is one of the most scoring topics. If you get a paragraph based question, then you are not losing any marks. You should not lose marks in liquid solutions at least. Okay. So with this, I would end the session, but not before I tell you a very, very important message. The message for today's session is that the life begins where your comfort zone ends. So life begins at the end of a comfort zone. Your comfort zone is solving easy questions. Difficult question आने से आप उसको छोड़ देते हैं. Comfort zone is maybe, let's say, chemistry. Comfort zone is not mathematics. Comfort zone is organic. Comfort zone is not inorganic. Comfort zone is physical. Comfort zone is not organic. But your ability to do good in an examination will start when you leave your comfort zone. एक reaction को ही ले लो. In a reaction, to reach from reactant to product side, उसको भी तो अपनी activation energy increase करनी पड़ती है. It has to increase the activation energy. It has to go all the way over the transition state barrier or the activation threshold energy barrier. एक transition state आता है. To get the transition state where it can be most energetic and most effective in forming products, it has to properly orient itself. It has to properly provide itself energy. So do you think that the reaction wants to be energetic? कोई भी energy लेना नहीं चाहता है. यूनिवर्स का रूल ये है कि सब कुछ अपनी एनर्जी रिड्यूस करना चाहते हैं. आई वॉन्ट टू बी वेरी कंफर्टेबल, बट वुड कंफर्ट गेट मी समवेयर? नो. द ड्रीम्स दैट यू सी with your eyes open are the ones which you can realize. The dreams that you are seeing with your eyes closed, and if you don't work on them, you can't realize them. So get out of your comfort zone. Get out of your comfort zone today, so that your life or your future, the next day, tomorrow, becomes a little more filled with struggle, but a lot better. Okay? So with this message, kids, I'll take leave, and I hope you join me in the next session, which is on electrochemistry, which is one of the most interesting topics of 12th standard chemistry as well as JEE chemistry, one of the most challenging concepts which will incorporate so many different things. I hope you will do that and solve questions on liquid solutions before you start with electrochemistry revision. But while you come for electrochemistry revision, please do solve a bit of it, so that you can run along with me. Thank you and bye-bye.